Hi Year 10, this lesson we're going to be learning about nonlinear relationships. Now, so far in our topic of coordinate geometry, we've been looking at linear relationships, okay? Linear, line, straight line. So, first thing I want you to tell me is, what is a nonlinear relationship, okay? Now, we've defined what a linear relationship is. Tell me what nonlinear means. What's a nonlinear relationship, okay? What are some types of nonlinear graphs that you already know about? So you may have seen some from last year or the year before. List some types of nonlinear graphs that you know about. Okay, you're not expected to remember them all or know them all yet, but write down the ones you already know about. Okay, then I want you to write down the key features of the nonlinear graphs that you've talked about and include the general forms of their equations. So write down the key features of your nonlinear graphs and the general forms of their equations. Something that you need to be able to do in this course and next year as well is to be able to know the equations of the graphs and what the graphs look like and their key features. So you should have stated probably about 3 nonlinear graphs that we've looked at. The first is a parabola. Okay, so basically when you throw something in the air, a ball or whatever, it travels in a curve called a parabola. Okay, the highest power in its equation is 2, so that should be in the definition of a parabola or a quadratic, and it's called a quadratic equation. And here are some examples. Okay, all quadratic equations. Main features, and we've listed these all before last year, so make sure you write them down. You actually have to learn these. Symmetrical, about its axis, and that is called the axis of symmetry. Turning point is the vertex, and that's listed here. Axis of symmetry is there. The direction of the parabola is called concavity, and if the coefficient is positive, coefficient of x squared, so the thing before the x squared, it's concave up. If the coefficient is negative, then it's concave down. Okay, happy and sad face, and we've gone through that before. The quadratic function gives the graph of a parabola, like we said, and we've been used to seeing, the general form of a parabola, which is y equals ax squared plus bx plus c. Okay, where a, b, and c are constants. Okay, constant just means a whole number, positive, negative. That's it. Here they've got f of x. It's just another way to write y. It's a function value of x. Okay, if a is bigger than 0, concave up, a less than 0, concave down. Okay, that's nothing new. We've seen all that before. Next type of graph is the hyperbola, and we've also looked at this before. So anything that looks like this, something over x, y equals something over x, or xy equals something, because that's just a rearrangement of y equals 1 over x. And this graph here too. These are all called hyperbolas. Okay, not hyperbola, but hyperbolas. To draw them, you need a few points and a smooth curve. Okay, main features, it's not continuous. Has 2 branches, and the branches are smooth curves of the same shape and size, symmetrical and in opposite quadrants. Okay, so basically if you've got y equals minus 1 on x, it's going to be in these 2 quadrants here. Okay, basically opposite. Also, the x and y axis are asymptotes, and we've seen that word before, and that just means that these lines, they never actually touch 0. They get very close. As you can see here, they get very close, but they never touch, and they can't touch them. Also, as the curve approaches the x and y axis closer and closer, like I was saying, it never touches, but the asymptotes are at right angles to each other. So the curve is also called a rectangular hyperbola. That may be something you didn't know before. And like I said, it's a function with equation in these forms. Okay, possibly those forms. For example, sketch y equals 1 on x. You need to use a table of values for hyperbola because you need to graph lots of points along the curve. So what they've done here is they've made a table of values, so they've chosen -3 to 3, but putting in all the finer details so that you can see where you get your corresponding y values. You'll notice that at 0, it's an asymptote. Okay, so there's not going to be a corresponding y value there. And this is what their graph looks like, y equals 1 on x. Notice how they're symmetrical curves, they're approaching the x and y axis but never touching, so that's important. Just remember that a hyperbola has a variable in the denominator of the equation, and it has two branches in opposite quadrants. Okay, the graphs are discontinuous, and they're also called reciprocal graphs. Okay. It's important when you graph a hyperbola also that you're labeling the key features. So notice here they've labeled the graph, and they've also labeled at least a point on the curve, and that's important. And of course x, y, and the origin should be labeled as well. The graph on the right has this equation, 2 on x. Now that can be written as xy is 2, and obviously the graph that is in these two quadrants here, okay, I've drawn a poor job of it, but you get the idea, would be -2, or y equals -2 over x. So I want you to have a go at some examples. And I'm going to get you to use a table of values for these. We're going to be learning more efficient methods later, but it is important that you know how to use a table of values and the roots from where we've learned how to do this. So for this one, xy is 12, xy equals 12. You should recognize that as a hyperbola. So create a table of values, probably similar to what they did. So make it comprehensive, as in a lot of points on your curve. Use a ruler when you do yours, because that would be better. And then you're going to substitute in here. Now we want to get the y value, so I'm going to rearrange this equation to y is equal to 12 over x. 12 divided by -3, -4. 12 divided by -2, -6, -12. 12 divided by a half, minus a half is the same as 12 times 2, so that's -24. So we got up to 12 divided by 0. Now that's an asymptote, so I'm just going to simply write that line there. Also 12 divided by a half, well that's the same as 12 times 2. 12 divided by 1, 12 divided by 2, 12 divided by 3. So you can see what this hyperbola is going to look like. Okay, and it's actually really important that you do know what it looks like. So think about how you'd graph that. Okay, I'm actually just going to quickly go through this one with you, so I'm just going to move this for a moment and graph it with you. So just quickly, we've got, so make sure you're using your ruler. It's a bit hard for me, but you should be able to just get your ruler out. Okay, so that's my y, x-axis, origin. Now I've got to go up to 24, so probably 2's, and I'm not going to have enough space here already, but equal spacings. Okay, so I've got 24, 12, that's this little one in here, 6, 4. Along the x I've got half, 1, 2, 3, half, 1, 2, 3. Clearly labeling everything. Gotta have equal spacings. Okay, mine may actually not work out. So you then have -24, -12, -6, etc. Okay. Going to graph this, -3, -4, well that's about here. -2, -6. So I know that you know how to graph this, and if you don't, it's pretty easy. So I'm just going and plotting points on the number plane, and that's going to form my graph. So I can see with this half of it, it's going to go through these points here, and it's going to get closer and closer to the x and y axis but never touch. And I'm going to get similarly over here. Okay, the same sort of thing. So you need to make sure that you are kind of graphing really accurately these points, and that's kind of really, really important. So it should be absolutely symmetrical going through those points. Arrowheads on it, label it, so this is x, y is 12, and label it with the original equation. And you should also label a point, so this is, say, the point -1, -12 here. Okay. Now, I want you to have a look at these questions. Does this graph cut the x-axis? Doesn't look like it to me. What is the value of y when x is 0? When x is 0, the value of y, well, there's no value of y when x is 0 because it doesn't touch the asymptote. Does the graph cut the y-axis? No, it doesn't. What is the value of x when y equals 0? So when y is 0, well, there are no x-intercepts, so nothing. In which branches, in which quadrants do they lie? Okay, remember with the quadrant naming, it's 1 in Roman numerals, 2, 3, 4. Okay, it's kind of anti-clockwise order. So they'd be in 1 and 3. What happens to the value of y when x decreases? So when x is getting smaller on your curve, what happens to y? Write down what you think. And the opposite, what happens to y value when the value of x decreases? Okay, so think about that carefully. And what happens when x increases as well? So as x is getting bigger, what happens to the y? And as x is getting smaller, what happens to the y? This one's a parabola. Again, graph it with a table of values and answer the questions below. Write a summary of what you learnt, any questions including a higher order thinking question, and in class we'll have time to go through these questions. You can ask me any questions then and work with your peers. See you in class, guys.